Hi, this is the first day of 4.9, which is related rates. Throughout this, I'm going to ask you some questions, and I recommend that at that time you pause the video so that you can think about your answer a little bit, and then start it up again when you're ready to hear the solution. Here's the first question. It's asking you if you took the derivative of A equals BH, then you will see the following pieces in the derivative with respect to T. So now would be a good time to pause the video, think about your answer, and then start it up again when you're ready. Did you pick the top left corner? If you see A, B, and H in the original problem, you would expect to see dA dt, dB dt, and dH dt in the derivative. You'll see other pieces as well, but these would be three of the variables that you would see. How about this question? Again, now would be a good time to pause the video. Since pi is a constant, we would not expect to see d pi dt in an answer, but we would expect to see dA dt and dr dt. Now a little bit of a backwards question. Now if you saw dB dt and dr dt, what variables would you expect in the original equation, and what might that original equation be? Agree with something with your partner or someone around you before you start the video again. dV dt and dr dt must be coming from v and r being in the original equation, and perhaps that original equation is the volume of a sphere. Or maybe you and your partner thought about something else that involves v and r. Next, we're going to look at what a single variable might be representing in a problem. So rather than, here's an equation, give me all the variables involved, instead, we have some specific details about each individual variable. And your goal is to figure out what variable would be represented by this statement, as well as what value. So for instance, in this very first one, the area increases at a rate of 2 square feet per minute. Something is going to equal 2. I want you to try to figure out what that is, as well as figuring out the rest of them. If you're completely stuck on the first one, then restart the video in just a little bit, and I'll give you some help with that one before you continue on to the rest. So if you're stuck with this problem, we can use some of the key words. One thing is that we're looking at the fact that we're talking about a rate versus an actual only the value. And so a rate of change, that's going to be a derivative, specifically the rate of change of the area or the derivative of the area. So the derivative of the area is going to be dA d something. And because this problem is specifically with respect to time, I'd probably say dA dt is going to equal 2. Something to also kind of notice if you're a little confused is that this unit is the appropriate unit of an area. This unit is the appropriate unit of time. See if you can figure out the rest of them. Notice that these answers are equal to rates of change, except for number 3, because number 3 is not about how the height is changing, it's about how the height itself is related to the base. And then also notice that in some of these problems, when it's talking about something decreasing, for instance in problem 2, that it's equal to a negative value. So both aspects of that are important. We're going to put all this together. This is going to start by using equations that we had on a white worksheet the other day. And one of those equations was about the area of a circle. So the area is pi r squared. Hopefully you can write that a little better in your notes. And I'm going to give you some information. I'm going to tell you that the rate of change of the area, okay, so that's dA dt, is changing at a rate of 3 centimeters per minute. I'm also going to be telling you that I'm interested in what the rate of change of the radius is. All right, so I'm going to denote that by saying it's equal to something that's unknown right now, specifically at the moment in time when the radius is 4 centimeters. Because we're talking about a moment in time, I want to be able to freeze that moment. Everything is changing until then, and so the radius is not always 4, it's just 4 at that one moment in time. So this belongs in an instantaneous rate of change equation, which is not what I have here. So what I'm going to do is take the derivative of both sides, dA dt. Let's see, pi acts like a constant, r acts like a variable, so it's going to be pi times 2r dr dt And then I'll take this information that I have and substitute these in to the right places. So I knew dA dt was 3, pi 2, those aren't going to change. I was specifically interested in this the moment that the radius is 4, and I would like to find dr dt in that moment. So it looks like on the right side I have 8 pi, so 3 over 8 pi will be my rate of change of the radius. And the units on this will match with r, and it will match with t. The radius's units would be centimeters, and times units would be meters. That would be my answer for that scenario. On the back of the white worksheet the other day, you had a formula that said volume equals 1/3 pi r squared h, and that was the volume formula for a cone. Today I'm going to look at the volume of a cylinder, and I'm going to give you some information again. And as I get this information, I'm going to kind of write it down in terms of its variable. I'm going to tell you that the rate of change of the height of the cylinder is 5 inches per second. I'm going to be interested in the rate of change of the volume of the cylinder, so I want to identify that variable as well. At the moment in time that the radius is 3 inches. All right, well, the other day when you were on your worksheet, you were told, like, here's the volume formula, and here's how we're going to treat the variables. Today, you're deciding how we're treating these variables. If I have a cylinder, and it's filling up, the radius is kind of unique in the sense that it's not changing. There's nothing real interested in the radius here versus the radius here. So the radius is going to act like a constant in this problem. The height, however, will act like a variable because the height at this point would be different than when it was completely full. The volume will also be changing, so I expect to see dV dt in my derivative. So we're saying that we're going to treat the radius like a constant. So the pi over to the r squared is just going to be treated like a constant. So the derivative of this function, derivative of the left side will be dV dt, the right side will be pi r squared, and then h's derivative, which is just going to be dH dt. If I'm looking for dV dt, well, that's the unknown that I want. I already know pi is pi. I knew that I'm interested in the moment that the radius is 3. Actually, it was always 3. And I was told that dH dt is 5 at this moment. So the rate of change of the volume at this moment in time is going to be 45 pi. Let's see, volume would have a unit of something cubed. This is inches cubed over time, or with respect to time, so it will be seconds. I'm going to have you work on some problems on a worksheet before you start the problems out of the textbook. If you don't have the worksheet already, pause this video and get one because I'm going to talk about some specific problems on there. On the front, there's 3 questions, 1, 2, 3, and I expect 1 and 2 to go well for you, and number 3 to be a little bit of a challenge. See how far you can get through problem number 3. Do your best at that one. Help each other out. On the back, I would expect problem 4 to work out pretty well for you. 5 and 6, you're going to feel like those are a little different, and I want you to try one of those. So you will have 1 through 4 done, as well as either 5 or 6. In every one of them that you're stuck on, I would expect to see a picture. So at this point, what I'm anticipating is that I would expect a picture for a minimum of 3, and then either 5 or 6. Do the best that you can, help each other out, and then start working on the problems out of the textbook. Good luck.